In this video, we're going to talk about the law of cosines, which is pretty similar to the law of sines, except in these situations, the sides of the triangle and the angles of the triangle will be related to each other according to the length of the sides of the triangle and the cosine ratios of the angles. So I have given you the three formulas. If you are looking at the side A, which is opposite to the side angle alpha, then A square is equal to B square plus C square minus 2BC cosine alpha. And we just keep repeating this pattern. So B square is A square plus C square minus 2AC times cosine beta. C squared is A square plus B square minus 2AB times cosine gamma. And eventually we can solve each of these relationships for the cosine value of the corresponding angles if I am asked to find the angular measurement for the angle of a given triangle. In any situation, you can always replace the angle gamma by the angle C, and that should be fine. So that's the form of the cosine rule that we are going to use for this video. So the first problem is use the law of cosines to determine the indicated side x. I know A is 29, C is 31, and we are going to round our answers to one decimal place. So let's write down the information that we have. A is equal to 29. And we have C equal to 31, and we are going to find the side x. So since x is the opposite side of the angle B, I can call this side of length small b. Then use the cosine rule. So we know that B square should be equal to A square plus C square minus 2 times A times C times cosine of the angle B. So that is 29 square plus 31 square minus 2 times 29 times 31 times cosine of 30 degrees. And because I eventually have to use calculator, I'm going to not worry about finding cosine 30 degree from the table, just do everything in the calculator. So let's see what we get. We have 29 square plus 31 square minus 2 times 29 times 31 times 30 degree and then cosine of that. So that is 244.8863. Now I'm going to take the square roots on both sides. And remember, since I'm talking about the length of the side of the triangle, I'm going to only use the positive solution. So we'll say B is equal to the square root of this number, and I'm going to round it to one decimal place. So it will be 15.6. That will be the length of the side. Answers my question. In our second example, we are going to find the indicated side x, just like the last problem. This time we are given with two angles. Angle A is 40 degree and angle B is 105 degree, and we know that the side small b is 50 units. Okay, so let's put the information down. So this is 40 degree, this is 105 degree. So clearly, very simple way of finding the side x will be using the sine rule for this problem. Okay, and why I say that, see, you can think about the side B over sine of the angle B is equal to the side A, which is the missing side X. This is the side opposite to the angle A, over sine of 40 degrees. And then I can multiply sine of 40 degree to both sides. So I will get X equal to 50 times sine of 40 degrees over sine of 105 degrees. And then we're going to find this value. 40, find the sine, multiply by 50, and then divide by 105, and I'm still taking the sine ratio of it. And then round your answer to 2 decimal places, so that should be 33.27. And I'm done. Find the indicated angle theta in this problem. Use either law of sines or law of cosines as appropriate. So I have been given with two sides, A and C, and I have been given with the angle C. So let's draw an arbitrary triangle first, and then label the vertices as A, B, and C. So if this is A, that means this is 9. This side is C, so length is 7. Angle C, whereas, is 45 degree. And I'm going to find the indicated angle theta, and so because both of these angles are missing and we are not clearly given with a picture here in this problem, so I'm assuming that we eventually have to find both angles. But if you think about this problem, it actually doesn't require us to do much to find the angle A, and that will be simple rule of sines. As I will say, 9 over sine of angle A is equal to 7 over sine of 45 degrees. So then, as we were doing last time, we will do the cross multiplication, and we will get 9 times sine of 45 degrees equal to 7 times sine of A. Because I'm finding sine of A, I would like to divide both sides by 7. So we'll get sine of A equal to 9 sine of 45 degrees over 7. And then find this value in our calculator, and we would know that we're going to round the answer to, say, 4 decimal places. Okay, so 45 degrees, take the sine of that, multiply by 9, divide by 7, rounded to 4 decimal places, I'm going to get 0.9091. And then remember, we're going to find the sine inverse of this thing, and also remember, your answers are going to be either the arc sine or the sine inverse of this value, 0.9091, or it is going to be 180 degrees minus the sine inverse value, the first quadrant and the second quadrant. Now, I'm not saying that both of them will be your answer, but we eventually have to check whether there is a possibility for both of them to be my answer. Okay, so 0.9091, if I take the arc sine of that, I get 65.3864 degrees. So eventually this other option is going to be 180 degrees minus 65.3864 degrees. So when I subtract, I get 6, and then 9 minus 6 is 3, 9 minus 8 is 1, and then so this is going to be 6, 1, 3, 6, And this is on the other side, 9 minus 5 is 4. And 17 minus 6 is 11. So 114.6136 degrees. Now remember what we were doing last time, we were calling one of these as A1 and the other is A2. And now we're going to find the third angle and check whether both of them or only one of them are the solution. So I still need to find C, but because I have two choices for A, I will do two choices for C. So C1 is going to be 180 degree, the total sum of the three angles in a triangle, minus the given angle, which was 45 degree in this problem, and then plus 65.3864 degrees. So let's simplify this first. So I get 180 degree minus these two added is this. So I get 69.6136 degrees. The other option is going to be C2, and that is similarly 180 degree minus the one given angle is 45 degree. Then this time my option is 114.6136 degrees. So I get 180 degrees minus 159.6136 degrees. So when I subtract, I get 3864, and 179 minus 159 is going to be 20. So both of them are nice legitimate solution. So I will say when the missing angle theta is required in this problem, I have two-fold solution. So I'm going to say that, so angle A has two choices, and the choices for angle A are 65.3864 degrees or 114.6136 degrees, whereas depending on which choice you have chosen, the angle C is going to be either 69.6136 degrees or 20.3864 degrees. And that concludes the problem. So let's see what else we can do. So this one is what problem? To find the distance across the small lake, a surveyor has taken the measurements as shown. Find the distance across the lake using the information. Assume that the points A and B are exactly along the shoreline, and A is 2.72 miles and B is 3.31 miles. So as you see in this picture, you can call A equal to 2.72 and B equal to 3.31. So because this is a side angle side situation, it will remind you of cosine rule. And I'm trying to find out the side C, which is opposite to the angle C. So remember the cosine rule I'm going to do for C square now. And that's A square plus B square minus 2AB times cosine of the angle between the sides A and B, which is 40.3 degree. And as we have seen last time, we're going to input values and then answer the question in calculator. So first you get 2.72 squared plus 3.31 squared minus 2 times 2.72 times 3.31 times cosine of 40.3 degrees. So let's work it out. We have 2.72 squared plus 3.31 squared minus 2 times 2.72 times 3.31 times 40.3 in degrees, and I take the cosine measure of that, and that is going to be 4.6216. So c squared is 4.6216. I take the square root and only take the positive solution because this is going to be the distance. So it will be positive. So c is going to be the square root of 4.6216. And I'm going to round it to 2 decimal places. 4.6216. Take the square root. So your answer is going to be 2.15. Now think about the unit given in this problem, that will be in miles, and that has answered my question. So now we can say that the distance across the small lake is 2.15 miles. This question is again word problem, and it is asking you to think about the situation where a pilot was flying in a straight path for 1 hour and 30 minutes. So this is the path, say. She then makes a course correction heading 10 degrees to the right. So if this is the way of the direction and you want to make a course correction and go 10 degrees to the right, then it will be somehow like that. So this angle here is 10 degrees, and then flies for 2 hours in the new direction. Goes far away. If she maintains a constant speed of 665 miles per hour, how far she is from her starting position? So she started here, and we want to know how far she has gone from here to reach this point. Okay, so one thing we can find out by thinking of this as a triangle, we can say this is angle A, B, angle C, and also remember this angle total is 180 degrees. So this much of the angle is 180 degrees minus 10 degrees, so that is 170 degrees. So angle A is 170 degrees. You also know the size, small c and small b, okay? Remember you have the constant speed of 665 miles per hour. And if you go for 2 hours, then you multiply by 2. So you get 2 times 5 is 10, 2 times 6 is 12, plus 1 is 13. So 1330, that's this one. And the other one was for 1 hour 30 minutes. So 3.5 hours, so 3 over 2 hours actually, 1.5 hour, I'm so sorry. So 1 hour 30 minutes is 3 over 2 hours, and then use the constant speed one more time. It's 665 times 3 over 2. So let's do that number in our calculator. 665 times 3 divided by 2, so 997.5. So this is 997.5. And remember, I want to know the distance between B and C, which is in the triangle the side A. So again, I have side, angle, side. So that tells me that I'm going to use the cosine rule to solve this problem. So a square is equal to b square plus c square minus 2bc times cosine of a. So these sides are 997.5 squared. I said degrees there, but that's just 1330 miles square minus 2 times 997.5 times 1330 times cosine of 170 degrees. Okay, so let's try to work it out. (997.5) square plus 1330 square minus 2 times 997.5 times 1330 times 170 degrees, but the cosine ratio of that. So, and I probably will round it to 4 decimal places first. So this is a long number. You're going to get 5376945. Point 9015. And remember, this is the distance square, so I need to eventually take the square root and only take the positive root because we are again talking about the distance. So A is the square root of this number. So I do 5376945.9015, take the square root, and we are going to round it to, because nothing is given, to 4 decimal places. So we'll say that it's 2318.8242. So that will be the final distance of the pilot from the starting point. And that answers this question for us. Okay. So in our next problem, 2 ships leave a harbor at the same time, traveling on courses that have an angle of 110 degrees. So it should be just 110 degrees. So think about the situation. You have these 2 ships going in 2 different directions where the angle between them is 110 degrees. If the first ship travels at 26 miles per hour and the second one travels at 25 miles per hour, how far apart are the 2 ships after 1.6 hours? And I am sorry for having this typos. Okay, so this is what I want to find out. Again, call them A, B, C as a triangle. So the first ship was moving at 26 miles per hour for 1.6 hours, and the second one was moving 25 miles per hour for 1.6 hours. What are these 2? So if you consider the side AB, the distance traveled by the first ship, then side C is equal to however much 26 times 1.6 is. So let's find that. 26 times 1.6 is 41.6. And if you consider AC to be the distance traveled by the second ship, so this is going to be 25 times 1.6. So 25 times 1.6 is 40. And remember, I want to find the distance between them, so I want to find out the side A, whereas I know that the angle A is 110 degrees. The same situation, side angle side, so cosine rule. So you say A squared is equal to B squared plus C squared minus 2BC times cosine of A. So put in the values, I get 41.6 to the power 2 plus 40 to the power 2 minus 2 times 41.6 times 40 times cosine of 110 degrees. Rest of the work we do in the calculator. And again, it is not asking me to round it to a certain decimal places, so answer should be rounded to 4 decimal places. Okay, let's do that. I have 41.6 square plus 40 square minus 2 times 41.6 times 40 times 110, and the cosine measure of that. So this is 4468.8030. And that is the square of the distance that we wanted to find out. So we take the square root now on both sides and take the positive root only, because this is the distance. So we get A equal to as much as the square root is going to go, and we will take round to 4 decimal places. Okay, let's take the square root. So it's going to be 66.8491 miles. And that gives us the distance between the two sheets after 1.6 hours. That concludes our study of cosine rule. Our next video lecture, we're going to start talking about complex numbers. In the meantime, you keep working on your homeworks and let me know whether if you have any question.